Okay, I have a question for you. What do these earthquakes all have in common? They broke all our rules. None of these earthquakes occurred on faults that we had mapped, or they were much larger than they should have been for the faults that were mapped using the characteristic earthquake fault-based modeling that Nilesh described this morning. And not only that, these are the 4 best mapped places on Earth. So we know this problem is much larger than it would appear here. Now, they can't all be black swans. Black swans don't fly in flocks. This is an indication that there's a problem in how we're building models, and we need to do a better job. And Temblor's approach is to build a globally uniform, globally consistent model for stochastic events. And we do this by blending past earthquakes and current strain rate rather than faults. And what we get is a 50,000 year event set, which has been independently tested now for 9 years and has outperformed its competitors. And I believe I can say this is the only stochastic event set that has undergone, in earthquakes, that has undergone any independent testing. So it's not because we built it, it's good because it tests well. Now, we make it easy for our clients to use this model by producing an event set API. So you can take any polygon and grab the earthquakes in that area in 40 seconds. And that's because it spins up dozens of Amazon servers. And here's California that you can see here for 50,000 years. Now, we go a step further and we combine this with our site amplification model and our ground motion model to get hazard curves. And we've looked at some hazard curves for earthquakes today. And here is for the Bay Area of San Francisco, where Temblor is based, the comparison between Temblor's curves and the USGS curves. And you can see that at short periods that drive the AAL, there's significant differences. Ours are lower. For longer return periods, they're very similar. Now, there's 2 ways to look at this. One, this is the only independent take on California because every other model vendor is using the USGS approach. Or 2, if you want to assume that the USGS is right, then what I want you to see is how similar these are. We have this same level of quality and consistency everywhere on Earth. The USGS only has it for the United States. And we can go one step further by combining our vulnerabilities to get full loss modeling, which we are also doing. Here's one of those black swan earthquakes, the 2023 magnitude 7.8 Kahramanmaraş earthquake for one of our clients. Now finally, what else we do is are able to account for the fact that earthquakes are in a kind of chain reaction. They are not independent events, they promote and inhibit each other, and we include that, and we're able to make changes in the event set to respect that in our data. So for example, if you're looking at Japan, based on a model that doesn't include the effect of the 2011 Tohoku earthquake, throw it away. Tohoku changed everything. That has to be part of a model to be successful. So thank you for being there. Thank you, our clients, for being there, and I appreciate the chance to talk with you.